And now I'll move on to section 2, which is about the software industry and quality. And there's this saying in the software industry that when you're producing a software product, you have 3 things to consider. You have quality, you have cost, and you have time. And the problem or the bind in software is that you can pick any 2 of those 3. You can make a product that is cheap to produce and that you make quickly, but then the quality will suffer. Or you can make something that's high quality and cheap, but then it's going to take you a long time. And you can make something that is high quality and is produced quickly, but then it's going to cost you a lot more money. And actually, it gets a bit more complicated than that, because as you, for example, pay for a large team of developers, you see a problem in that there are more and more people who have to communicate in order to produce the product. But I think that quality, cost, time triangle is a neat simplification of some of the issues that are caused when working in software projects. And of course, a blockchain is fundamentally a software product when you are actually getting down to the nuts and bolts and developing it. Now, one of the problems that we have in software development is that we've built up this culture of, I think it was Facebook's Mark Zuckerberg said, move fast and break things. Back in the 70s, 80s, and 90s, when you were programming, you made these software products and you put them on a cassette or a floppy disk and you mailed them out to customers. Now with the internet and with all the software libraries we have, you have things like web app programming and mobile app programming, where you can push a product out and then as you discover bugs, you can fix them and automatically update them. I'm sure you're all familiar when your phone says it's updating this program, or if you ever use something like Microsoft Teams, for example, you'll find that you miss your meeting because it spends 5 minutes updating to the latest version because there's some fix pushed out there. One of the problems this web app programming paradigm has brought is that the decision is made again and again to go for reduced cost and decreased speed because you can catch up with quality later, except that it's not quite as simple as that. The architectural decisions that are made in a rush can have long-term ramifications and can actually be quite difficult to unpick and untangle. So that's kind of a summary of where we are in the development world. If you go back to, for example, you can look at things like the Apollo moonshot, something that I like to call moonshot programming. They actually wrote computer programs that ran on the spacecraft, and they were faced with a problem that once they launched, if there was a software problem, unless it was a very, very simple one, it couldn't be fixed. And we used to also have this kind of problem with embedded software, where if a device had a program running inside it, like a watch or some early IoT device, you flashed the software into it, it was very hard to update it. There might be 1 or 2 upgrades in its life cycle. And so the program had to be a lot more careful about their coding, and it required a lot more testing in order to ensure that you weren't shipping out something that then later turned out to be a dud and you had millions of these devices sitting out there that were dead. So we do some history that we can draw on in order to look into how programming should be done to ensure that the quality is as high as possible. But the vast majority of programmers, they are now familiar with this move fast and break things paradigm. So this leads me on blockchain. And the issue that you have with blockchain is that it goes back to this more inflexible programming paradigm, that if you launch a blockchain and you have nodes that start running to maintain it, and you've set all the parameters for your blockchain, it becomes very, very hard to make changes. If you decide, for example, that you want to move from one consensus system like proof of work to another one, such as proof of stake, you need to convince the participants on the blockchain that is indeed a good move. So you really want to make sure that you get it right, or as right as possible, the first time round, because in programming, you can't get it 100% right immediately. There will always be bugs, but you can make sure that the list of bugs is as small as possible when your code is put out there. And so if you're looking at deploying a blockchain, you should be paying close attention to quality. And similarly, if you're deploying smart contracts, which are programs that run on a blockchain, again, because of the nature of blockchains, they can be very hard to update. There are tricks that you can use in order to upgrade your smart contracts as time goes on, but they are tricks and they have some issues associated with them. So again, before a smart contract is launched onto a blockchain, it really pays to make sure that the quality is as high as possible. So how do you go about that? Well, it does really boil down to testing. And one thing that the blockchain does is you'll find that for any blockchain worth its salt, there is a parallel blockchain running known as a test net. And in some cases, there can be 4, 5, or even 6 test nets. So Ethereum, for example, has at least 4 that I can think of off the top of my head, for people to check that everything is working before they spend real money to deploy their program. So I'd sort of go back a bit to quality and its sort of sibling security. How do we end up with it being nice to have? And the answer there is that it boils down to basically business practices. When you're looking to sell or gain traction for a software product, you are primarily looking at making a profit. And you can ask yourself the question, if you go to buy a car and you're talking to the salesperson, what kind of questions are you going to ask them? You're going to ask them, what's the top speed? What's its fuel efficiency? Can I have a sunroof with that? I think very few people ask a salesperson, how testing did this car get? It's not something that's at the top of your mind as someone purchasing a car. What's the safety of this car going to be? And the reason for that is that we rely on regulation. And we rely on the fact that the governments have passed laws that say that need to meet certain thresholds before they can be sold. You cannot go and produce a car and mount a big spike on the steering wheel anymore. The bad news is that there were actually models of cars like that in the 50s. Experience has shown us that's not a good idea, and laws are passed that said cars have to meet these certain standards before you can sell them. And this is the problem when you look at something like blockchain programming. We don't have the same kind of regulation in place, and we don't have that demand at the moment. Again, in traditional programming, if you're going as an enterprise to buy some software from another corporation, you may make demands. You may say that I want it to meet ISO 9000 standards, for example, or you may demand that there's a high quality security audit on it. But even those things have problems. For example, I worked as an ISO standards compliance officer at a previous employer. Sometimes it felt a bit like rubber stamping to me. You checked all the boxes, but there wasn't really a passion on the part of the company to make sure that we met these standards. It was just, can you please make sure that we can tick the boxes, and that when an auditor comes in, they agree that those boxes had been ticked correctly. So this is the thing, quality and security become business decisions. They're not anything in terms of kind of developer pride, or certainly in the early stages, for example, startups, they go on the back burner because they're expensive. And you want to make sure that you've got market traction, that you've got a good customer base before you start putting money into those kind of things. Ironically, it makes them seem like a bit of a luxury, which, as you can see in the long run, they're definitely not. I guess I can compare it to having fire insurance on your house. Anybody who has a house, the odds of it burning down are very low, but you know that the impact, if it burns down, is going to be very high on the life that you're leading. But the cost of fire insurance is relatively low. Imagine if it costs you 20 or 30% of your yearly salary to get insurance for your house. Would you still buy it, or would you take a gamble and say, I'm just going to risk that it doesn't burn down? And another thing we see is that as a result of this, when you look at salaries, you'll find that test engineers get paid less than developers, although get paid more than tech writers. For example, a startup or a fledgling blockchain project, it does make commercial sense to do as little testing as possible. It's just one of those unfortunate things in the way that business works. So that's covered testing and quality in software, hopefully.